Alright guys, this is going to be a nice little review of circuit identification, power ground side switching, figuring out which one the control wire is, energizing the solenoid, and then also checking the computer driver. So the first thing I'm doing is this Purge solenoid that's over here to the right, and without looking at a wiring diagram, we are back probing these two wires to determine circuit design. The one to the left reads 12.35 volts. As you can see, I'm moving this over to the other wire, and the other one reads the same voltage, 12.33. See that again, 1235. There might be a little clue there as to which side is the control wire, possibly. 1233, 1235. No, it's not. So same voltage on both sides, 12 volts on both sides. That tells us this is a ground side switched solenoid. So then the next step in determining which one the control wire would be is to simply disconnect it. We disconnect it, do the same readings. I'll start with the one to the left. 1235. Unplug it. You see it stays at 1235. And I do have a battery charger on this, so this number is going to be changing as we roll here. So that's my feed wire. The one to the left is the feed. And to show this better, I will plug it back in, go back to the wire on the right. Having trouble getting my T-pin in here. $12 volts on the one to the right. Disconnect it, and we read 5 volts. So we have a little bit of a variable to this one. This is a bias voltage, and what I'll do is maybe a part 2 to this, and we'll talk about this bias. But 12 volts plugged in, 0 volts unplugged would tell us this is my control wire. 12 volts plugged in, 5 volts unplugged still tells me this is the control wire for this solenoid. So the next step would be in energizing this solenoid. Can we do it manually? Can we do it with bidirectional controls? And so what I want to show you is a manual test with a test light. Am I confident enough that this is my control wire? I am. I have an incandescent test light connected to ground. Will be the first one. I'm going to touch on the alternator battery post to show you I have a good ground. And I'm going to ground this solenoid. I'll let you watch the voltage too. We'll ground the solenoid with the test light, and you can see that that test light is lighting, and we're dropping that voltage down to 7. So really not grounding that as much as we need to. I hear no clicking, so that would be the test, is test light to ground, touch on the control. We should hear the solenoid click. We have no clicking. So this test light's not carrying enough current to energize this solenoid. So let's get a quick current measurement on this test light. To do that, I have an ammeter connected, and we'll go DC amps, move my lead over to the amp port. The black lead is connected to battery ground, so what I need to do is I need to connect my test light to battery positive. You see when that test light touches ground, now it lights. This lead is now connected to ground through my ammeter over to the battery, and what this should do is light my test light right here, and you see that it's doing that. And so now I'm doing an amperage measurement of my test light, and make sure we don't have a glare here. See 0.186. That's 186 milliamps that test light is drawing on this circuit. Alright, so let's do something else here too. Let's take this a little bit further, and keeping in mind that I'm holding a jumper wire in my hand with this ammeter, can you untangle that around? Thank you. So my ammeter is a jumper wire with a gauge on it. Am I safe in grounding this circuit completely, and I am. So what we're going to do is I'll ground it through my ammeter, which is my jumper wire. We'll listen for a click, and then we'll focus on what the amperage actually is on this solenoid. So listen. Turn that battery charger off for a second. I think we'll be able to pick this sound up just a little bit better. All right, listen close. Okay, cool. Turn that battery charger back on. I'm sure you heard that. So, of course, a jumper wire is good enough to energize the circuit. Let's take a look at the amp draw. I'm using my ammeter to give us that number. Little connection issues here. 375 milliamps is what this solenoid draws. So that's pretty typical. I have listed in my book 300 to 500 milliamps. And you can see my 180 milliamp test light was not enough to energize this solenoid. So it's a little bit higher current of 1. And jumper wire is key sometimes. Now, just because a solenoid clicks does not mean that that solenoid is fully functional. So the last part of that would be we could take the vacuum line off of here, start the vehicle, and energize and de-energize the solenoid while we're listening for vacuum to occur at this port. This would be the purge line or the vent line that goes to the charcoal canister, and it just makes it easy to do that I can take that cap off. So I'll show you the same thing with the engine running. And I'm not sure the camera will pick this part up, but we're going to listen for that vacuum here as I energize that solenoid. Let that idle down for a second. Take a listen here. Again, I'm using my ammeter as my jumper wire. Because we're making a vacuum leak. So listen. Got vacuum there? No vacuum there. So that would be the complete test for that solenoid. That is a good solenoid, and that's how you do it, ground side switched. Now the last part of this would be if you needed to check this driver for this solenoid. There's multiple ways to do it. We can of course use the voltmeter to do it, but the scenario when you'd want to check a driver would be when the solenoid has malfunctioned and we can't use the voltage in the circuit. So what we do is we use a test light to check that computer driver, although I'm missing one more piece here. I wanted to show you a LED test light on this same circuit and do an amp draw measurement there. So my LED is connected to ground, and you see that LED light is lighting. Look at the voltage. I'm only pulling down to 12 from 12.3, where my incandescent, see that one more time. Incandescent light don't have a good ground. Pulls it down to 7.8. LED 12. Let's get an amperage measurement of this LED light real quick too, huh? Oh, I gotta switch my test light, sorry, to battery positive, because my ammeter is connected to ground. And there's my amp draw of my LED light. It's 11 milliamps, 12 milliamps, much lower. You're not going to be energizing circuits with an LED test light would be the lesson there. So checking the computer driver, what we do is we simulate a faulty circuit, right? And in this faulty circuit, what we have is, say, an open, you know, we're reading 5 volts here. That's that bias voltage. Again, not a concern for this part. I'm going to go to my home tab, my scan tool. I'm going to go to my functional test menu, and you may not be able to see this very well on the camera, but I'm going to stay zoomed out. Go to ATM tests. What I'm going to do is pick my Purge solenoid, and on this screen up at the top I have an on-off setting, and I'm just going to select on. So my test light is going to be connected, I'll show you both, it'll be connected to battery positive. And what we want to do is touch on that control wire. And what we want to see is this light turn on and off whenever I command it to do so. So scan tool. And the fact that this light's flickering on and off is suggesting that this is a pulsed circuit. And if you know anything about Purge solenoids, they are pulse width modulated. And no, I didn't hurt the solenoid by energizing it fully before. But what that tells you is that is a good driver. That'd be test light connected to battery positive, turn the circuit on, look for a pulse. Is there a concern here for that driver? Am I overloading the computer with this test light? No, I'm not. Normal current in this circuit is almost 400 milliamps. This test light's only 180, no problem. If there's a concern on a computer driver, the safer tool to use would be the LED test light. You saw the current draw on this LED was only 11 milliamps. So on lower current circuits, it might be to our advantage to use an LED test light when you're concerned. In particular, maybe for the lower current stepper motor, idle air control valves, or maybe a relay coil. I'm comfortable with my 200 milliamp test light, but this is definitely a lower current one for checking computer drivers. So that would be your computer driver test using a test light. Now there's another way, and I didn't show this the first time I did it, but right now you can hear the solenoid clicking. And the other thing that we can do is we connect this lead back to ground, go back to my meter, and I was on DC volts, and you can see that that voltage is now showing me an average. Good lesson on average voltage. Is that really what it's doing? No. Voltmeters are not fast enough. So if you want to see what it's actually doing, what we need to do is go to the graphing meter or the scope, and then what you can see is what that signal is actually doing is an on-off pulse. Now we have some spikes at the top because of magnetic field collapses. That's not a problem, but this would be another way that you could check the circuit without the test light. But you need to understand that this test relies on both a good driver and a good solenoid to be able to do that. If this solenoid's open, see, a lot of that was my T-pin was loose. If this solenoid is open, you can't use this test. You have to use a test light. So another tip for checking computer drivers. Test light's the preferred method when we have a faulty solenoid. We want to make sure that that driver didn't take a hit. So I want to show you one more, and that's going to be a power side switched. And this isn't going to be exactly how it is because it's the output side of a relay, but we're going to go to this AC clutch and let's plug in these numbers. So let me turn this off, and we'll go back to my digital meter just so you guys can see this easier and I can stay zoomed out on what we're doing. All right, 1239. So next step, going over to my AC clutch. Oh, and by the way, since we're here, when you're done using an ammeter, you have to take this out of that amp port. Don't leave it there, because amperage doesn't matter what you set up here. If you leave this over there, it's a jumper wire. I got wires everywhere.
I wonder what your full box looks like.
toolbox is like all wires. All right, so let's start with the voltage measurement. And I'm just going to back probe the two connectors at the AC clutch, and we'll see what we have. You guys tell me what you think. Wire to the right, I have 0 volts. Wire to the left, I have 0 volts. What type of circuit is this? It is power side switched. Now, there are possibilities of wiring problems, of course. This is not a foolproof method. Like, we could have an open feed on a ground side switch, would give you the same thing, but this is a known good circuit, so that's telling me this is power side switched. Now, is there a way for me to determine which one of the two wires on this AC clutch is the feed or the control, and which one's the ground? A power side switch circuit will have a constant ground, and so what I can do is I can disconnect it on the harness side and then connect a test light to battery positive. I'm just going to use my incandescent light for this. Use either one. Test light to battery positive. See, the test light is lighting. And then what I'm going to do is back probe this connector. I'll use my pin here. And the one to the right, touch on that, and my test light is lighting. The one to the left, touch on that one, and it does not light. So now I know what my AC clutch is doing. It's powering. Control is on this side, the ground is on that side. If I plugged it in and did that, we'd have to be careful because, look, with it plugged in, it lights. And the reason it's lighting, power is going in through my test light, through the AC clutch coil and coming out to ground. So it's using the clutch coil as ground. And so right now, both wires, moving back to the right, both wires show me positive. Sorry, both wires are showing me a ground. I'm connected to positive. And that is why when you do this, you need to unplug it. You'll see when I unplug this that that's going to go away. So that is my control. That's unplugged, unplugged, plugged in, unplugged, plugged in. That's my control. So we could, let's do an amp draw measurement. One of the things we definitely won't be able to do on an AC clutch is to energize it with a test light. Amperage is much higher on these. I'll give you a quick amperage measurement. We'll go, remember that needs power now, so my ammeter will go to a battery positive source with the one lead. We just use the alternator here again. And then the second lead, we want to go back to DC amps, move this over. And I think that should be good right there. Yep. And what I'm going to do is energize the clutch. Watch. And I'm confident that this is the power wire for this, or the control. It's switched on the power side. Listen. Show you the amperage, 3.2 amps. There is no way that you're going to, there is no way that you are going to energize a 3 amp circuit with a test light. You see, I'm using a jumper wire to do it. 3 amps. And let me shut that charger off. I'll let you guys watch the AC clutch over here. At least listen for it. I don't know if that's in the shot. Let me see. If you watch in the screen right here, watch this clutch, you should be able to see it move. Okay? Small screen, you'll see it. So I'm energizing the clutch. I was able to figure that out doing voltage measurements. It was power side switched. And then I figured out which one my control wire was, and then I energized it. If this was a lower current circuit, the test light would have worked. Final thing would be the bidirectional control of this. Let's say the clutch was not working, had malfunctioned. It would really just be a voltage reading here would tell me that. You can watch, we'll do both at the same time. But knowing it's power side switched, we would connect a test light to ground and we would command the circuit to turn on and see if the test light lights. So I'll show you both the voltage. Well, actually I won't be able to show you voltage because I will be on the scan tool for this. And my scanner's still in the shot here.
Yeah.
So scanner, I'm going to go exit and I'm going to bidirectionally turn this clutch on. I'm going to find my AC clutch. It's up here at the top. And I know some of you are thinking, well, what if I don't have a scanner to do it? Well, start the truck up and go inside and turn the AC on and see if your test light lights. Turn that switch on. You're going to see this is going to pulse on and off. Let me move my hand out of the way. You can see the clutch being pulled in and out. And this would be a valid test. Even if this clutch didn't work, let me simulate a bad clutch here in that if we had an open, that clutch is no longer engaging, but can you see we still have control? And this would be how we do a control circuit test on a power side switch circuit using a test light. Show you one last thing and we'll be done for this part. Well, let me leave that on. Hit the home tab, go back to my scope multimeter, show you the on-off signal here. The reason we can see this one, where we could not see the last one, is this is a lower frequency and the meter has time to catch up. So if I go back and go to my graphing meter, show you a little bit more what that's going to look like, this high-low signal. I can actually increase my time base now to see more of that. Power side switched. A little bit different in that the on time up here is high, where the ground side switched one, the on time was down low, and so you see our spikes are exactly opposite of what they were on the other circuit. So the next segment, what I'll be doing is some bias voltage testing, but this was a great review of circuit identification, energizing and output, and then checking computer drivers.